Lesson 2-14 Practice. What do you know about polynomials? Question 1. We know these things about a polynomial function f of x. It has exactly one relative maximum and one relative minimum. It has exactly 3 zeros, and it has a known factor of x minus 4. Which of the following is a sketch of the graph of f of x given this information? All right, it has one relative maximum and one relative minimum. That means it has a hill and a valley. There's the hill, there's the valley, hill, valley, hill, valley, and the last one you can see only has a valley. Has exactly 3 zeros. Okay, this one touches the x-axis 3 times, this one touches the x-axis 3 times, and this one also touches the x-axis 3 times. And it has a known factor of x minus 4. That means one of the zeros is 4, because if you replace x with 4, you get 0. 4 minus 4 is 0. The first graph touches the x-axis at 4. That graph does not. That graph does not. Question 2. May graphs a polynomial function f of x that has 3 linear factors, x plus 6, x plus 2, and x minus 1. But she makes a mistake. All right, her zeros in the graph are -1, 2, and 6. You can see not -1, 2, and 6. So we look at the function, not the graph. It should be, the first zero should be -6, because -6 plus 6 equals 0. The second zero should be -2, because if I replace x with -2, -2 plus 2 equals 0. And the last one should be 1. If I replace x with 1, 1 minus 1 is 0. So that's -6, -2, and 1. -6, -2, and 1. Question 3. Here's a graph of a polynomial function with degree 4. You can see it looks like a W. Select all the statements that are true about the function. The leading coefficient is positive. You can see both hands are up in behavior. Right hand up, left hand up. So that is true. The leading coefficient is positive. The constant term is negative. All right, it crosses the y-axis above the x-axis, so that is not true. It has 2 relative maximums. No, it only has one hill, one relative maximum. It has 4 linear factors. That means it would have 4 zeros. 1, 2, 3, 4. That is correct. One of the factors is x minus 1. That means if I replace x with 1, I would get a 0. So it touches the x-axis at 1. It does not. It touches the x-axis at 2. One of the factors is x equals 2. Yes, we just talked about that. There is a relative minimum. That would be a valley between 1 and 3. No, the valley is not between 1 and 3. The valley occurs after that and before. Question 4. Complete the explanation of the degree and behavior of f of x equals 2 times x cubed minus 3 times x to the 5th minus x squared plus 1. F of x has a degree of 5 because its leading term is -3x to the 5th power. It has the highest exponent of 5. Since the leading term is -3x to the 5th power, as x gets larger in the positive direction, that means it goes right, it's going to go down. F of x gets larger in the negative direction. As x gets larger in the negative direction, that means left. F of x gets larger in the positive direction. That means up. One hand up, one hand down, since the degree is odd. Question 5. Refer to the graph. Which of the following explains whether this is the graph of g of x equals x minus 1 squared times x plus 2, or h of x equals x minus 1 times x plus 2 squared? Well, you can see it has a 0 at 1, and it is touching the x-axis. That means that term must be an even degree. So x minus 1 must be an even degree. You can see in g of x, x minus 1 isn't an even degree. And you can see in h of x, x minus 1 has an exponent of 1 since it isn't there. So it's g of x, and it's because of the value x equals 1. This is the graph of g of x. The shape of the graph near x equals 1 implies a factor of multiplicity 2. Question 6. Kieran thinks he knows that one of the linear factors of p of x equals x cubed plus x squared minus 17x plus 15. After finding that p of 3 equals 0, he suspects that x minus 3 is a factor of p of x. Which of the following is a diagram he can make to check if he's right? Well, the vertical column here should be x minus 3, since one of the factors is x minus 3, not x and 3. So you can see the last two diagrams say x minus 3. We could look at the like terms. Let's look at this, the x term. That's negative 17x. If I look at this diagram, negative 12x plus negative 5x is negative 17x. Look at this diagram, 12x minus 5x is 7x. We could also check the squared terms. 4x squared minus 3x squared is x squared, which you can see is the second term in the polynomial. Last question. The polynomial function b of x equals x cubed plus 8x squared plus 5x minus 14 has a known factor of x plus 2. Complete the following function so that b of x is rewritten as a product of linear factors. Be sure to write each factor with its terms in order from highest to lowest degree. B of x equals x plus 2 times, all right, I'm going to copy this polynomial before the equal sign. When you paste it in, remember Control V, you have to change this to cube, Shift 6, 3, change this to squared, Shift 6, 2, and you can see we're going to take this whole polynomial, and we are going to divide it by the known factor, which is x plus 2. So in the denominator, I'm going to type in x plus 2. When you divide that trinomial by x plus 2, you get a quadratic that touches the x-axis at negative 7 and 1. That means one of the factors is x plus 7, and the other factor is x minus 1. And you can see you get the same quadratic. I'm going to try to copy it, Control C, and paste it in my answer. Control V.